Many years have been spent on the research and development of hydrogen fuel cell technology by Toyota, and the company has already introduced the hydrogen-powered Toyota Mirai automobile. An electric motor is powered by the electricity produced by a fuel cell inside of the Mirai. This electricity is created through a chemical reaction between hydrogen and oxygen. Due to the fact that this reaction produces only water as a waste product, the Mirai is an emission-free car. On the other hand, Tesla manufactures electric vehicles that are powered by lithium-ion batteries that can be recharged. These batteries are used to store electricity that is produced by a power source that is external to the device, which is then utilized to power an electric motor. The operation of an electric car results in zero emissions, and the overall cost of ownership for an electric vehicle is typically lower than that of a conventional gasoline-powered vehicle. Several considerations need to be made in order to answer the question of whether or not Toyota's hydrogen combustion engine might successfully replace Tesla's electric automobiles. To begin, the cost of creating and delivering hydrogen fuel is now more expensive than the cost of producing and distributing electricity. In addition, the infrastructure necessary to support hydrogen-powered vehicles is not yet as readily available as charging stations for electric vehicles. Because of these issues, it might be difficult for hydrogen-powered vehicles to displace electric vehicles in the near future. Despite this, Toyota's hydrogen combustion engine may still have a considerable impact on the car industry, particularly in contexts in which electric vehicles may not be the most suitable option. For instance, hydrogen-powered vehicles may be more ideal for heavy-duty commercial vehicles, such as trucks and buses, which require longer ranges and quicker refilling times than electric vehicles are able to give. Examples of such vehicles include tractors and transit buses. How can Toyota get costs down? Toyota might potentially lower the price of automobiles powered by hydrogen combustion engines in a number of ways, including the following. 1. Increase the production scale. One of the most effective strategies for reducing the cost of any technology is to increase the manufacturing scale of that technology. If Toyota were to raise the volume of manufacturing of its hydrogen combustion engine vehicles, the business would be able to take advantage of economies of scale, which would result in a decrease in the cost of manufacture for each individual unit. 2. Research and development. Toyota may choose to make investments in research and development in order to enhance the effectiveness of its hydrogen combustion engine technology. This may involve the creation of new materials or designs that would enable the engine to perform more efficiently, or it may involve the improvement of production methods in order to lower costs. 3. Collaborating with suppliers. Toyota may be able to cooperate with its suppliers to build more efficient supply chains for hydrogen fuel cells and other components that are necessary for its hydrogen combustion engine vehicles. In this context, working with suppliers could mean collaborating on the development of novel materials or production processes that could result in cost savings. 4. Incentives offered by governments. Governments from around the world are providing a number of different incentives in order to encourage the creation and use of hydrogen fuel cell vehicles. Toyota may be able to cut the price of its vehicles powered by hydrogen combustion engines by working with various governments to get tax credits, subsidies, or other forms of financial assistance. 5. The creation of necessary infrastructure. One of the most difficult obstacles that hydrogen combustion engine vehicles must overcome is the absence of necessary infrastructure to support refueling. It is possible that Toyota, in collaboration with various governments and other interested parties, may establish a network of hydrogen refueling stations. This would increase the desirability of the technology among consumers and lower its total cost of ownership. Bringing down the price of vehicles powered by hydrogen combustion engines will need for a multi-pronged strategy that includes a mix of research and development, collaboration with suppliers and governments, and the construction of infrastructure. What is needed for infrastructure? It is necessary to construct a hydrogen fueling infrastructure in order to sustain hydrogen-powered internal combustion engine automobiles. The following is a list of some of the most important aspects of such an infrastructure. 1. The production of hydrogen. In order to put hydrogen to use as a fuel, it must first go through the process of manufacture. At the moment, The steam reformation of natural gas is the process that is utilized most frequently in order to produce hydrogen. However, in addition to that, there are also other technologies that can be employed, such as electrolysis, which uses renewable energy sources. After the hydrogen has been created, it must be transported to stations where it can be used as fuel. 2. Hydrogen storage. Hydrogen is kept in high-pressure tanks at filling stations. Handling these tanks properly calls for specialized gear and extensive training, as they are required to be kept in a highly secure condition at all times. 3. Fueling stations. Fueling stations are locations where hydrogen may be refilled into the tanks of hydrogen-powered cars that use a combustion engine. Installation of hydrogen fueling stations can be expensive because of the unique equipment and safety features that are required. 4. Distribution network. The hydrogen that is created at the production facilities must be transported to the stations where it is refueled. To transport the hydrogen from the production facilities to the fueling stations, either a distribution network consisting of pipelines or a fleet of tanker trucks is necessary. 5. Safety rules. As a result of the highly combustible nature of hydrogen, safety regulations are absolutely necessary for the infrastructure that supports hydrogen fueling. These laws need to be put into place so that the production of hydrogen, as well as its storage, transportation, and refueling, is done in a manner that is not hazardous to either the environment or the general people. The establishment of a hydrogen fueling infrastructure calls for a substantial financial commitment, as well as close cooperation between various levels of government, private industry, and other interested parties. However, once it is established, it has the potential to provide an emissions-free alternative to conventional gasoline-powered vehicles. This is particularly useful in heavy-duty transportation applications, where the requirements for range and weight make battery electric vehicles less practicable, which is the safest option. Vehicles powered by hydrogen combustion engines and vehicles powered by electric motors are both widely regarded as safe. However, distinct precautions must be taken when utilizing each type of technology. Hydrogen gas, which is used as a fuel in hydrogen combustion engine cars, is extremely flammable and can provide a threat to public safety if it is not handled in the appropriate manner. However, contemporary hydrogen fuel systems are built with many safety mechanisms to minimize mishaps, such as pressure relief devices and automated shut-off valves. These systems are also designed to be more environmentally friendly. Additionally, hydrogen gas is less likely to cause an explosion since it is less dense than air and has a faster rate of dissipation in the event of a breach. Electric vehicles, however, make use of high-voltage batteries, which provide the possibility of receiving an electric shock if they are not handled in the appropriate manner. On the other hand, electric car batteries are constructed with many safety features, such as heat management systems and automated shut-offs, in order to reduce the likelihood of accidents occurring. In addition, electric vehicles do not emit any emissions while they are operating, which can lead to an improvement in the quality of the air and a reduction in the health hazards associated with emissions from vehicles. Both hydrogen combustion engine vehicles and electric vehicles are generally regarded as being risk-free modes of transportation to operate. Nevertheless, each powertrain technology has its own unique set of safety concerns that must be taken into account. Appropriate safety precautions must be taken in order to guarantee the safe operation and maintenance of cars, regardless of the powertrain technology used. Toyota has achieved tremendous progress in the development of hydrogen combustion engine vehicles as a potential replacement to conventional gasoline-powered vehicles. These vehicles could replace traditional gasoline-powered automobiles. The business has made significant investments in research and development and has brought various hydrogen fuel cell vehicles, such as the Toyota Mirai, to the market. In comparison to battery-powered vehicles, hydrogen combustion engine automobiles from Toyota offer a greater driving range and require less time to refill. This is one of the most significant advantages of hydrogen combustion engine automobiles. Because of this, they are particularly well suited for heavy-duty transportation applications, where battery electric vehicles may not have the requisite range or payload capacity due to their limited range or payload capacity. In addition, Toyota has been successful in lowering the price of automobiles that are powered by hydrogen combustion engines. This has been accomplished by enhancing the manufacturing processes and increasing production quantities. Additionally, the company has made investments in the creation of a hydrogen fueling infrastructure, which includes the construction of fueling stations as well as the establishment of a network of hydrogen suppliers in collaboration with other businesses. However, there are still a number of obstacles that need to be overcome before hydrogen-powered internal combustion engines become mainstream. These include the requirement for further infrastructure development, as well as the high cost of manufacturing and storing hydrogen. Despite this, Toyota's advancements in creating and promoting hydrogen combustion engine vehicles have contributed to promote awareness of this technology and to expedite the transition to a transportation system that is more environmentally friendly. As a result of its forward-thinking approach to car design, battery technology, and charging infrastructure, Tesla has been at the vanguard of the shift toward electric vehicles from the very beginning. The business has proven that electric vehicles are not only feasible but also desirable, as they offer superior performance, efficiency, and sustainability in comparison to conventional gasoline-powered automobiles. Tesla has made great headway in the field of electric vehicle development, as seen by the company's introduction of a number of models into the market, including the Model S, Model X, Model 3, and Model Y. These automobiles have been lauded for not just their performance and range, but also their safety and the svelte and fashionable appearance of their exteriors. One of Tesla's most significant achievements has been the creation of a powerful charging infrastructure. The company's supercharger network offers drivers of Tesla vehicles throughout the world choices for charging their vehicles that are both quick and convenient. This has helped to overcome one of the primary obstacles associated with the widespread adoption of electric vehicles, which is the anxiety associated with driving long distances without access to a charging infrastructure. The dedication of Tesla to environmental preservation has been an important factor in the company's overall success. The corporation has high targets for decreasing carbon emissions, including the use of renewable energy sources and the development of energy storage systems. One of the ways these goals will be accomplished is through the use of renewable energy sources. Tesla is demonstrating that sustainable transportation is not just viable, but also profitable, by incorporating renewable energy into its products and operations. This demonstrates that sustainable transportation is not only conceivable, but also economical. In general, Tesla's progress in producing electric vehicles has had a transformative impact on the automotive industry and has helped to pave the way for a more sustainable future. This is one manner in which Tesla has contributed to making the world a more sustainable place. It is expected that Tesla will continue to be a driving force for innovation and change as the market for electric vehicles continues to expand. Tesla now holds the top position in this sector. In conclusion, the argument over whether hydrogen-powered internal combustion engine vehicles or electric vehicles are superior is not yet over. Both of these technologies come with their own set of advantages and drawbacks, and the choice of which one to implement rather than the other will be based on a number of different considerations, such as cost, range, infrastructure, and environmental impact. Battery electric vehicles have a shorter range than hydrogen combustion engine vehicles, but they can be refueled more quickly. Hydrogen combustion engine vehicles also have the potential to be emissions-free modes of transportation. However, the creation of an infrastructure for fueling hydrogen-powered vehicles is still in its early stages, and the cost of manufacturing and storing hydrogen continues to be quite expensive. Electric vehicles, on the other hand, have seen substantial growth in popularity over the past few years. This is due to developments in battery technology, as well as the growth of charging infrastructure, both of which have made electric vehicles more appealing to customers. Battery electric vehicles offer a technology that is not only more straightforward but also more established. In addition, battery electric vehicles have fewer costs of maintenance and a smaller carbon footprint than hydrogen combustion engine vehicles. In the end, the exact requirements and interests of individual consumers, corporations, and governments will determine whether hydrogen-powered internal combustion engine vehicles or electric vehicles will be the better option. Both of these technologies have the potential to make a contribution toward lowering emissions caused by transportation, and fostering a future that is more environmentally friendly,